In this tutorial, we'll briefly review use of the online tool that accompanies the manuscript by Ravi et al., which allows you to obtain the predicted perceptual similarity of any pair of odorant mixtures. This web tool is based on the results of Ravi et al., particularly those seen in Figure 2 of the manuscript. Here in Figure 2c, you can see the correlation between the predicted similarity of every pair of odorants and their rated similarity by about 30 participants. Each dot reflects a comparison of two complex mixtures, and you can see that our correlation between predicted and actual is an R of 0.76. So our prediction of perceived similarity from predicted similarity is quite powerful. It was powerful enough to build a model that allowed us to answer Bell's 100-year-old challenge, if you will, of predicting the perceptual similarity of rose, violet, and asafoetida. So here you have the comparisons of rose to violet, rose to asafoetida, and violet to asafoetida. In darker blue, the rated similarity, and in lighter blue, the predicted similarity by our model, which you can see performs quite well. In the middle of the tool, you have a two-dimensional map which reflects the pairwise perceptual distances between 4,000 different monomolecules, here presented in a two-dimensional MDS space. These 4,000 monomolecules are the ingredients you can use to build various odorant mixtures and then obtain the predicted perceptual similarity of the odorant mixtures that you build. The simplest path to using the tool is to use the pre-built mixtures that we've generated. And I'll demonstrate that here using the two examples from the manuscript itself. So for example, we can select mixture 1 and select the odorant rose. And you can see the components of rose appear now here in red in OdorSpace, and this is our number 1 mixture that we've chosen. Then you click mixture 2 and select violet, and it's shown up here in orange. And then you select mixture 3 and select asafoetida, and now which showed up in blue. And now we can click calculate, and these 3 meters give us all the pairwise distances. So mixture 1 to 2, which is rose to violet, is 0.282 radians, which is different. Mixture 2 to 3, which is violet to asafoetida, is 0.786 radians, which is extremely different. And mixture 1 to 3, which is rose to asafoetida, is even more different. It's 0.810 radians, which is again extremely different. So we've concluded this comparison. We can hit reset, and all the system goes back to its baseline position. Example also taken from the manuscript is that related to Chanel number 5. We go and select from our pre-mixed mixtures Chanel number 5 imitation. It shows up here. It has 12 components, so this is admittedly a very simplistic example of Chanel number 5. And then as mixture 2, we add what we created as Ravi number 5. No components in common with Chanel number 5, but designed using our measure to smell exactly the same. And we calculate the difference. And the system is a bit slow right now, but there we go. It's 0.011 radians, which is likely indiscriminable. So this is a very, very close pair of odorants. By contrast, we can now add as a third mixture LV number 5. LV number 5 has the exact same components as Chanel number 5. The only difference is that we change the intensity of one of them by 20%. So now again we calculate, and we can see that LV number 5 is in fact very different from both Ravi number 5 and Chanel number 5. So this relates to the legal aspects, if you will, or the copyright aspects of our manuscript, where you can see that we can generate 2 mixtures with no overlapping components that will be likely indiscriminable, or 2 mixtures that have exactly the same components but a difference of intensity only in one of them, and they'll be very different from each other. Now let's hit reset and see another path to using this system, where rather than using the pre-built mixtures that we made for you that you can select from this list, you will now build your own mixtures. So you can go to mixture number 1 and then go and start selecting the components that will build your mixture. You can select the components by either cast number, CID number, or common name. I'm going to go by CID number, and I'm just going to select a particular CID. This happens to be benzaldehyde. And down here you can get the descriptors that 3 common public sources associated with this given molecule, if indeed they have a descriptor. So in this case, you can see that both the Good Sense and Sigmund Aldrich describe this as sweet nutty almond, balsamic, but the Actander does not give any reference odor associated with this odorant. So we selected this odorant. You can see it shows up here in OdorSpace. We now have to decide what percentage of our mixture this odorant molecule is going to be. So let's say I'm going to make 10% of my mixture using this odorant molecule. We then have to declare at what intensity we used it. Now, these values have a default, and the default is set by the concentration of a suggested smelling in the Good Sense. But let's say if we used benzaldehyde at a much lower concentration, we can rate its intensity with our participants and lower its perceived intensity. Once we've completed all these things, the percentage in the mixture and the perceived intensity, we add it to our mixture. And as you can see, mixture 1 here at the right now has CID number 26 at 10% of the mixture. Let's choose another CID to add 244, which happens to be benzenmethanol. Again, you can see it showed up here in OdorSpace. Let's add this as another 10% of our mixture. We'll hit add, and now you can see here in the list our mixture has 2 components in it already, CID 126 and 244. And now let's just add one more CID. So this happens to be hexitol. It showed up here. We'll add it at 25%. And it has no verbal descriptors associated with it. Now, I don't have to reach 100%. If I finish this mixture now, the system will just add diluent as the rest of the mixture. And now I switch to mixture number 2, and I go through the same process. So I select any old cast number. This happens to be 2,3-butanediol, which is fruity and buttery. And I'm going to make this 30% of mixture number 2. I'm going to add it. And I'm just going to select some other CID, and this is something that's actually ammoniacal and fishy, and I'm going to make this 5% of my mixture, and I'll add it. And now I can go to calculate, hit calculate, and here is the difference between these 2 mixtures. They're 0.364 radians apart, which is extremely different. So these are easy discriminable mixtures. You can see them up here in the 2 colors that we selected. Now, rather than selecting components for our mixture from the pull-down lists, I'm going to select them directly from OdorSpace. So you can click any point in OdorSpace, let's say this point, and find out what its name is and how it smells, and add it to your mixture. I'm going to add 10% of this to my mixture. And I'm going to take this thing really close to it in OdorSpace, which smells sulfurous. And I'm going to make this 10% of my mixture as well, and add it. And then I'm going to go to mixture 2, and all the way to the other end of OdorSpace. I'm going to take this thing and add it at 10% of my mixture. And I'm going to take this thing next to it and add it. This is woody amber cedar. And add it as 10% of my mixture. Once again, I have 2 mixtures. I'm going to calculate their difference, and you can see that their difference is really extreme. It's 1.2 radians almost, which is a huge, extreme difference between odorant mixtures. Now I'm going to build a third mixture, and I'm going to build it out of odors here somewhere halfway in OdorSpace. So I'm going to use this component at 20% of this mixture. This is cooked meaty nutty. I'll add it, and I'll add this thing here, which is green fruity nutty, at 10% of this mixture, and I'll add it. And now I'm going to compare all 3 mixtures, and I'm hoping that 3 will be closer to 2 into 1 than 1 to 2 themselves. So let's calculate, and there we go. So I was predicting that the differences from 3 will be smaller than the difference from 1 to 2, and that's indeed what happened. So you can see the 1-2 difference is almost 1.2, and the 2-3 is 0.7, and the 1-3 is 0.9. So consistent with the map, the perceptual difference between this mixture and this mixture is larger than the perceptual distances between this and this, or between this and this. So here again, you've computed the perceptual distances between 3 odorant mixtures. So now I'm going to end with showing you a final and particularly exciting path to using this tool. So first again, we'll reset it to be sure we're starting from scratch. Now, before I showed you how to either select previously built mixtures or build your own mixture from either the components in cast CID or name, or the components in just directly from OdorSpace, but you can also just go by odor. So using this approach, we can actually go by the odorant characteristics. So let's go to fishy, and here we have a fishy molecule show up. It's 2-propanol 1-amino. Let's add it to our mixture at 14%. So we'll add it, and now we can highlight OdorSpace in this area. There's our fishy molecule. Let's add to our mixtures a few neighboring molecules, which will smell probably quite similar. We'll add this, and we'll add this. So there's our first mixture. Now we can zoom out to OdorSpace again. There's our first mixture in the fishy area. And now let's go find something very different. Fruity citrus rose. There we go. Fruity citrus rose right about here. Let's add that in 10% to our mixture number 2. Mixture number 2, let's give 10% of this. And now let's highlight this area. There it is. And let's add a few neighbors to this mixture. So let's add this, for example, which is fruity green. And let's add this, which is indescript. Add. And let's zoom out. So I've actually built a fishy odor around here, and I've built a rosy odor around here, and I can calculate their distances, and unsurprisingly they're extremely different. And here I've in fact designed 2 odorants using this tool. So in a way I can use the tool for odorant synthesis, as it were. Finally, I should point out that you can click download to either download this figure as is, or download the raw data for all the pairwise comparisons and the components of the mixtures that you've built. So this more or less covers the functionality of this web tool. Remember to always hit reset before you start over, and remember to flip between the mixtures as you build them.